Hello everyone. Today I am going to demonstrate how to create a Sigma rule for detection engineering. I am going to demonstrate this with a malware sample that I found on VirusTotal. We are going to first do the malware analysis together to understand how this malware operates, and then we will quickly dynamically analyze this sample by executing it on a sandbox environment. We will go through the event weaver together to understand how this malware operates in the backend. We are going to use the sysmon to be able to understand the event logs that is being created, and then continue to create the Sigma rule by using the Visual Studio Code environment from scratch. So let's quickly start. I'm going to share the sample with you on this YouTube link. So let's start by first analyzing the sample. I know that this sample is being compiled in C#, so I'm going to use DNSSpy to understand what's going on. I go to the model namespace and then main app functionality. You can see that this malware sample is capable to get some command line from the threat actor. Let's go back to there. The threat actor can execute this malware with a command line debug, detail, example, full to get more detail during the execution. But at the end of the day, what we are seeing here is they are using executing assembly functionality to execute a PowerShell script inside this malware sample. The Calambur 2021.ps1 is the PowerShell script. It is being executed when the user execution occurs. It is inside the resource section of the malware. If you click on it, you are going to see the main payload, which is designed to perform RDP backdoor on this Windows operating system. We know that threat actors are using the RDP sessions to get remote access, and this sample is performing command and control over an Onion website. Over here you can see they utilize Windows built-in binary curl.exe to perform this action. We can see that they are using PowerShell. It's an encoded script. We can able to deobfuscate that, but we are going to focus mostly on the detection of the command and control activity that abuses the Windows built-in binary curl.exe. That will be today's session for the detection creation. They also use another backdoor utilizing the SSH from a GitHub page of the OpenSSH. They downloaded this client, and then they are setting a firewall rule to be able to get the SSH access. You can see that there is another downloading attempt happening. It is downloading the Tor browser inside that zip folder, installing himself as a service, so they can able to do connection to the specific Onion page. So these are basically the indicators of compromises that we can observe so far. I did a fast forward a little bit because I wanted to focus on the detection engineering part of it. You can also see that how does the RDP session being backdoored over here. A new user was created by the threat actor after the execution of the script. Threat actor is creating an admin account with a specific credentials. They are using net.exe built-in functionality to create a new user and then use this credential to log in back to the victim device. You can see that there is another firewall rule, a firewall policy to allowing access to the local port of the RDP session, remote desktop session. They are also utilizing scheduled task. You can see that over here to gain persistence access to this remote device. So let's start from the curl.exe session. Curl.exe functionality. This is that using this onion page, very likely owned by the threat actor, managed by the threat actor who developed this malware, and it is capable to executing PowerShell code being received by the threat actor, probably back and forth. So they got initial access and also the RDP backdoor by using this malware. So before going through the creation of the detection, for this session I used the sysmon. Let me clear the sysmon logs real quick. Sysmon is a free Windows tool. You can simply use it to create your detection algorithms. It will give you detailed event, what will happen to your victim host. You will get information about it. I will quickly demonstrate you what I am meaning by that. So I'm going to execute this malware on a secure sandbox environment to see what's going on the event viewer. I'm going to refresh this page. So as you can see, we are getting a lot of process create logs related to this malware, and we can see the scheduled task creation. I can also increase the size so you can see easily. Here's the scheduled task creation. There's a one file being dropped out to the Windows update file path. We can quickly check it out. You can see the malware is dropping multiple files, possibly understanding which device being executed. They collect IP address, username, and other metadata related to this device. There's a PowerShell command that was being observed. We also see the same exact things when we do the malware analysis by understanding this PowerShell script. But we can also do this without malware analysis, simply dynamically executing this malware instead of the static malware analysis. Let me refresh this. So what I am going to get is simply this one, because we wanted to create a detection that specifically look for command and control activity that is abusing curl.exe with the Tor browser proxy. You can simply identify that proxying activity. It uses SOX 5 proxy to make connection to the Tor network, and then from Tor network proxy to the attacker controlled Onion website. So we are going to focus on this today to understand what's going on. So let me copy this log and go over to the VS Code. Today I am using the VS Code, but you can use any kind of software you simply want. I will log.txt. What I wanted to do is, let me do a little bit of the zoom in so you can see it much more easily. I am using an extension from the Sigma rule extension support for the VS Code. By using this, you can create a simple template like I did right now. You can simply download this, enable it, create a test YAML, a test signature, and then write new rule. If you hit enter, you are going to get a sample template for your rule. We also have the event log over here. Yeah, okay, so this is the template of the Sigma rule. What we are going to do is trying to detect this event. there's a process create event being used for this, and we can see the command line over here. So let's go quickly. First thing first that we are going to do is we need to give a description, a metadata for this rule. It is generating us a simple template, but we can do simply like detecting call.exe abuse by threat actor, something like that. Give it a simple description. You can give a reference, any kind of reference you want. You can go to the curl.exe page over here, maybe, if you want, as a reference, or you can put your blog post if you are creating a threat research article. The author name is simply the name of the author. I'm going to enter my name and surname. Tags section is basically your MITRE ATT&CK TTP list, let's say. So you can enter each TTP ID or software ID by using attack dot and the TTP ID or software ID. But remember that the starting of here, like the letter T is entered by the lowercase. If you enter it capital case, you get an error message. It's a very simple thing, but just to keep it reminded yourself. So each Sigma rule should have a log source, which is usually a category. This time it is process creation. And in terms of product, we are using Windows. We don't have a service right now. Let me delete this one. And after that, we have a detection section. You can create as many selection as you want for your own detection. But in this case, we are going to focus on which is this time it is write it like this, ends with curl.exe. So we are focusing on the curl.exe. You can see the image field populated in the log. So what we are doing here is simply trying to match between this Sigma rule fields for the selection and inside the detection area with the event log. That's what we are doing. So this is the first thing that we need to do, which is we are interested in the image section. Next is the command line, because we saw that threat actor designed the PowerShell script to execute a specific command line. Contains, so the command line contains, let's go to over here, for example this one, and next thing is probably .onion. You can see that it's a onion web page. So this page could be changed anytime. What we are trying to achieve is even if threat actor change the URL, we should need to be able to detect this activity. I'm getting one error message. Let's try to get rid of it. Yes. So we are going to detect this event. It's a proxy event abusing curl with the onion page. So this is one simple detection to be able to detect that event. But the question is, what will happen if the threat actor simply change the name of the executable? Since we are focusing fully on the curl.exe, this time it is being executed under system32. It's a default Windows binary. But in some other cases, it could be downloaded from third-party domains and then dropped to your temp folder or dropped to any folder the attacker chose. But the problem is it could be named as something else instead of the curl.exe. So what I wanted to use is simple metadata sections like company or original file name, product, description. So these are the metadata of the executables, and I wanted to insert this information as a detection. So that's what we are going to do right now. I wanted to detect first the description section. Let's copy that, paste it. That should be contains this specific string and product, the curl executable. So we are trying to increase the rate of the successful detection by doing this, but at the end of the day we need to know that if we are dealing with a threat actor who can able to change the simple metadata inside the executable, they are going to still bypass this detection algorithm. So we need to know that there is always a possibility to evasion or bypass in any case, almost any case. If you wanted to increase the rate of the successful detection, you might consider to using hash or imp-hash of this executable, or using different techniques instead of relying on an executable. So let's wrap up this one. You can see that there is condition. What we are going to do is, for the condition, there is only one single selection. If you wanted to increase this selection, you can create multiple of it. Like you can go on and focus a little bit of the parent image, for example, because this executed through the PowerShell. Again, it really depends on you. So let's quickly go over, save this one. For the level and false positiveness, these are also sort of metadata section, like this one, title, ID, description, etc. It is going to give the Sigma rule users information about what you are created. For this demonstration, I'm going to leave it as it is in the template. I wanted to perform a detection by using this Sigma rule, and for that, let me quickly clear the logs so we have much more easy to understand what's going on. For the detection purpose, for the testing purpose, I'm going to use an open source tool called as AURORA. It's simply a command line tool that help you to do the testing of your Sigma rules inside your sandbox environment. Sigma rules can be generated and converted over to other query languages, like for Elasticsearch or Splunk environment if you have. But for the testing purposes, I will suggest you to first execute your in a sandbox system and create your Sigma rule, and then test it over time before the production. So for that reason, we are going to use AURORA. If you wanted to see the documentation, the link for their GitHub page, I'm also going to edit that inside the description of the video. So I downloaded the agent. You need to have a simple free license for that. You can quickly grab that with a quick email. So we are going to use minimum level, which is low. It's basically the level here. You can enter it. And for documentation, you can simply go to the Sigma rule documentation page to understand basic fields like log sources, conditions, filters, and so on. So you can see that there are different levels, and maybe you can see which type of metadata you can enter and so on. So you can check out the documentation for the further information about the fields. So let's quickly execute the AURORA. But before that, I wanted to show you, since I created this rule, reveal in File Explorer, test new. So you need to enter the Aurora and then go to the signature path, go to Sigma rules. I simply deleted every single Sigma rules being downloaded over here because there are default previously written Sigma rules being downloaded. And since the sake of the demonstration, I wanted to delete everything and only put one single Sigma rule, which is that we created, this one, test new. We can also name that. Since it was named as Calambur, I will put the Calambur name. It was being named by the threat actor as Calambur, and something like Tor curl. Something like a metadata that will give a brief information about it. So let's execute Aurora agent. So the rule is created and then saved under the Sigma rule file path. You can see that agent is currently running. I will go back to the sysmon logs, clear it again, and execute the malware. So after the execution, you can see that what's going on the on the background. You can see that curl.exe being executed. If I go to the top a little bit, you can see that Sigma match has been found, test new, rule outer. This gives you a simple description. So it is basically do the detection, and if we go back to the event logs, and you can see that the same event log being captured by the sysmon, and we can also able to detect with this Sigma rule that I created right now. We are also able to get the log file because I mentioned it in the command line. If you go to the logs menu, you are going to see a possible match that we created recently. You can also see like what's going on in the backend. You can maybe increase the rate of the detection through reading this document, reading this log file. So that's simply it for today. We can go over and continue to create more detection rules by using this simple methods for this malware. But overall, I hope that this demonstration gives you a simple idea of how we are doing malware analysis and dynamic to static analysis, and then doing the Sigma rule creation for the detection through the event logs. The event logs that I use, again, sysmon, but if you're using other log mechanism for your system, it could be also cloud environment, but you can do very similar approach over here. Testing your Sigma rule, seeing that it has been alerted, and then continue to publish on the production environment. Also, another note that I am using Sigma rule converter to understand if there are any errors or issues related to the syntax, because it is a YAML format, and if you are writing from scratch, you are probably going to add small adjustments needed before the testing. If you saw any error message over here, you can use that simple web page to simply convert your Sigma rule into different environments, for example Splunk, Elasticsearch, and etc. You can change the different formats. You can create your own pipeline to basically focus on your own environment. Like if you are using different EDR solutions or CM solutions, by creating single Sigma rule, you can able to use that single rule for different environments. Again, thank you very much for your listening, and if you like what you saw, please subscribe and give it a thumbs up to this channel. Thank you very much.